Hello there. In this video, I want to talk about another aspect of the QPython package that has to do with service interruptions and priorities where the interruptions are due to preemption. That is, maybe some of the different customers have different priorities. So I put that in here in the form of these priority classes. There are two classes of customers in this queuing network model, class 0 and class 1. Of course, we could call them different things. And class 0 has priority of 0, and class 1 has a priority of 1. And I don't know, it's a network that in this case has 5 nodes. And here, just for simplicity, really, that I've just said copy out these different distributions 5 times for each of the classes, because it's not really the point of the example, frankly. So we've tried to simplify this. What I want you to pay attention to in this example is actually just this priorities classes, where we've added, yes, the priorities themselves, but we've also added this list, one element for each of the 5 nodes. So, and also you can ignore the routing here. It's basically, there are 5 nodes, there are rivals at each node, there's service at each node, and customers enter the service, enter the network at any of these nodes, and then immediately leave without going to other ones with... It does make, actually, now that I think about it, one of these, the reroute, a little bit silly, but anyway, we'll get to it. So the point that I want to talk about in this video is that when you have different priority customers and you have preemption, meaning that if a higher priority customer arrives in a queue and there's a lower priority than it customer being served, during preemption, you get that the higher one will actually bump the lower priority one, and there's different things that could happen in that situation. So the first case is false, meaning no preemption at all, so that situation doesn't happen. That even if a higher priority customer arrives at a node and sits in the queue, they actually still have to wait for lower priority. You don't interrupt service. This is pretty common, by the way, because especially if the customers are literally people, that they don't really like their service being interrupted all that much. And so it kind of, I don't think this happens very often, but that you have preemption, but it's worth considering and having these different options depending on what you're modeling. So there's a resample option that says that the preemption does happen. So the higher priority customer will bump the lower priority customer out of service. And what ends up happening for resuming service after the interruption is done is you'll get resampling. And what resampling in this context means is that they have their service resampled altogether. That is, there's a service time distribution up here for either of these classes, and you just simply will sample again. It's a little bit silly in this case because I chose deterministic distributions here, but of course you could have non-degenerate distributions such as an exponential. So resampling, you just sample it again, so you don't know how much time, but you know the distribution for how much that time will follow. There's just restarting, which is you had already sampled an amount of time. Let's say that a customer was sampled to take 10 units of time to complete their service, but they were interrupted, say 7 units into their service. They would still have to go through 10 units of service again when they resume. They just restart at the beginning. Whereas resume is to say, well, you've already gone through 7 units of time out of the 10 that was originally sampled, so you only have to go through another 3 units. So restart is to basically be like, start again from the beginning, but with the same amount of time as was previously sampled. Whereas resample is starting again from the beginning, but with a new random sample for the amount of time. But resume is where you can actually pick up where you left off. And so you're going to be, if you were almost done when your service was interrupted, then you're almost done when you resume. Then rerouting is to basically say, actually, when you get interrupted, when your service is interrupted, you will go to a different node. But that will follow according to the routing rules, and that's where I mentioned there's something a little bit silly that I put in here, which is really you just leave the network. But in cases where you've got routing behavior that actually does send you to another node, that this routing behavior will say where to go with what probability, or when we get into the more complicated, sophisticated ways of routing, that it will follow whatever those rules are. Okay? So that in a pinch is the different types of preemption and resuming type of rules of what happens when you resume the service after being interrupted. Now let's take a look at running this example. So if I go run preemption, you can see, just to actually jump back for a moment to the example, that I set up a simulation with that network that we defined above. We run for 1,000 units of time, because why not? It's a number. And then we get all the records. And here I'm just printing a counter of how many of each of the record types. So the record types will not tell you which of these different scenarios of reroute, resume, restart, etc. But it will tell you whether it was an interruption versus a service for that record. There we go. So in this case, there was 707 services, and there were 118 records that were service interruptions of any of the types that we specified. Okay, so hopefully that gets you started if you were thinking about how to deal with interrupted services and priorities with the CubePython package, and I will catch you in the next video. Take care. Bye.